Hello there! Today I'll be reducing palladium with formic acid. This is not a tutorial, do not repeat anything shown in the video. There is a number of ways of reducing palladium ions that make metallic palladium. The easiest way there is by cementing it with a more reactive metal. There is just one problem. Reduced palladium sticks to the metal you are using to cement it. This passivation, or more accurately plating effect, greatly reduces the rate of the reaction. I have a 3-part video series demonstrating that. While I could use dimethyl glyoxime, DMG for short, to precipitate palladium as a complex and then obtain palladium powder by thermal decomposition of said complex, DMG is kinda expensive. So I searched for another reagent that would not strain my wallet this much. I found a procedure using formic acid as a reducent that looks very simple, so I tried it out. Here I have a solution that should contain silver and palladium, but also some tin and nickel. First step toward obtaining the palladium from it is to remove all the silver. I will do this by precipitating it with salt. Here I have a comical amount of it. Way too much for the amount of silver that's probably present. I dissolve the salt in distilled water. And slowly poured it into the beaker containing silver nitrate. Let's see if I have any silver in the solution. Yup, I sure do. Let's add a bit more for a good measure. This is how the solution looks after giving it 1 hour to settle down. There's still colloidal silver chloride floating in the solution, which is not ideal. I'll try to filter it out through a double-stacked filter paper, but I already know a lot of it is going to pass through. Because this is my first time doing formic acid reduction of palladium, I believe 200 milliliters is more than enough for a first test. I brought out the old rusty to heat the palladium solution to somewhere between 60 and 80 degrees Celsius. Well, solution is warm enough. You don't want it boiling hot. As you can see, the current color is dark brown or perhaps slightly orange. Solution is clear. I will add small amounts of 85% formic acid And if everything works out, we should see the solution go black because of the formation of small particles of palladium. Let's add a bit more. A surplus is highly beneficial for such a reaction, especially because there is still some nitric left in the solution. I'll thoroughly mix it and start a time lapse to hopefully capture the color change. After like a minute, the reaction started quite vigorously. Large volume of gas is produced. I hope it won't boil over, and I will vacate the premise because that's nitrogen oxides. I put the beaker into a plastic bowl that should catch any liquid that may overflow and left the area. Well, this was a lot more exciting than I wished or planned for, but it does appear to be working. There are silvery metal particles both floating on the surface and settling down on the bottom. Powder is a bright silvery color, which is not something I expected. At the time, I thought the reason for this was that the slow reduction led to the growth of larger particles that better reflect the light. But I was wrong. Well, honestly, I have no idea if all this white powder is actually palladium. I'll have to look this up. I did a bit of research and found out I have made palladium chloride. I am quite certain this is the case because the solution lost its reddish color and turned green, so the palladium must be in the precipitate. Stannis test confirmed this. I believe the chloride formed because I ran the reduction at too low of a pH and I had a surplus of chloride ions in the solution. So it turned out I was doing the reactions at way too low of a pH. Some claim that the optimal pH for formic acid reduction is between 2 and 3. I will try this first, and if it doesn't work, I'll increase the pH to 4. When I reached pH of 4, white precipitate crashed out of the solution. I believe this is zinc hydroxide, and I have to filter it out. As you can tell by the color, palladium is still dissolved in the solution. Now, let's add the acid and see what we will see. Increasing the pH did take care of all that nitric acid, so we hopefully won't see a cloud of nitrogen oxide this time. There was a gentle reaction producing small amounts of gas, but no precipitate was formed. 12 hours later, there is no palladium powder to be seen. I honestly have no idea what I'm doing wrong. I used urea to denox the solution and boil it for 2 hours. There were no positive changes observed. If any of you have experience with this process and know what I'm doing wrong, please comment so I can learn and improve my process. I do not like failure, but failure certainly likes me. Thank you for watching, like, subscribe, and see you next week.